harmonic motion. What is it?
It's a retarding force.
Yep.
That is directly proportional to the
Proportional to what? Displacement. Yeah. From some origin, fixed point. Yeah. So, simple harmonic motion is motion. Now hang on, let me think what lingo word I want here. Oh yeah, but it's not set in stone. You can, change it a little bit. Simple harmonic motion is motion in which the force acts towards the center such that it is proportional to the displacement, or no, I won't say displacement, I'll say distance from the center. I have a feeling that probably looks a little bit different to how I wrote it last time, but it doesn't matter. I'm hitting on key points each time.
There's no period.
Don't think it's absolutely crucial to mention that. I think mark-wise there's 2 marks. So the first thing is acting towards the centre will probably get you a mark. And the fact that it's proportional to the distance will get you a mark as well. Sure, why not? Let's just mention it's periodic as well. So if you really want to, you can type in a simple harmonic motion is a type of periodic motion in which, etc., etc. Makes you feel better? Yeah, I mean it's 2 marks. So if you wrote simple harmonic motion is a type of periodic motion in which the force acts towards the center such that it is proportional to the distance from the center, I'd give you the 2 marks for that. Okay? Okay, can I go on to the next part now? It's important for these definitions that you understand what's the key points, and then in the exam use your best English to explain those key points. So what are the key points here for simple harmonic motion? Yeah, but I didn't mention that.
Forward and towards the center.
Towards the center and crucially proportional to the distance. Crucial. Okay. That was part A, now on to B. A simple pendulum has a small ball at the end, okay, and it's alright, it's released. So you have this pendulum swinging here. First question, what would happen to the time if the bob was replaced by one of the same shape and size but twice the density? So we have this here, and then I replace it with another ball, and this ball is more dense. Hey, come on in. Don't be late for my class now. What would happen?
Density becoming period remains.
Period remains the same, correct. Why?
Because it doesn't influence by density.
Why not?
Because the period is 1 over transfer frequency. So
No, you almost had it. What's the formula for the time for a pendulum? 2 pi root L over G. Do you change 2 pi? No. Do you change the length? No. Do you change the G? No. So the time's the same. So the answer is no change in time.
it's 2 pi squared root G over D.
The formula is 2 pi root L over G.
Yeah.
Yeah. All the numbers in that are the same, aren't they? I was shocked by how many people last year got that wrong. Shocked. No change in time. Okay. What would happen to the time if the pendulum amplitude was halved? So what would happen to the time period of the pendulum if the amplitude of vibration was halved? So in other words, instead of starting the pendulum here, you started here with half the amplitude.
So you say,
Yeah, I'll just put dot 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 here. No change in time, because once again the formula doesn't care about what's being changed. Again, I repeat how shocked I was when people got this wrong last year.
So even though the amplitude and the density change, time never change.
Not for the pendulum. Okay. Can I scroll down to the C part? Okay. C part. Now we're given the length and we're given the amplitude. These are all meters. Super easy. What is the time? 2 pi root L over G. So provided you know how to use your calculator and you're not stupid, you'll be able to get full marks here. Pi root L over G, I got 1.817 seconds.
it's two, we're using 9.81.
Yes. Okay. Who remembers for simple harmonic motion? In fact, I think we had this week actually. What's the formula for maximum velocity?
A omega.
Yeah, omega A. Or whatever you're using for amplitude, whatever, it doesn't matter. So, do we know the omega? We don't, but we have a formula for omega. What's the formula? It's T equals 2 pi over omega. So, we can just put 2 pi over T. Hey, that's why they asked me for the T. Times A. So all you have to do is take this answer and put it in there. And out comes another 2 marks or whatever it was. 2 pi over my answer times 35 times 10 to the power minus 3. What did you get? Tell me, I want you to do it with me. What is it? Yeah, 0.121 meters per second. I remember, Tanish, we had a discussion about this one as well when we did it in mechanics. So maybe you can tell us, when in the motion, or when will you have maximum velocity? Yeah, well, give me a description, a word that describes it more in space. Lowest is what I wanted. Yeah. I know what you meant, but just to make sure we get the marks at the lowest point.
Well, what if it was free instead of pendulum?
Well, then we can use equilibrium, I suppose. Yeah.
But if it says the pendulum is lowest.
It just makes it clear. There's no question about it. What is the maximum acceleration? Who remembers that formula? I think it's just A omega squared. Yeah. So, or if you actually look at it, that's actually the same thing as omega v, isn't it? Because what's A omega? It's v, isn't it? So I'm just taking a little bit of a shortcut. If I just multiply my last answer by omega, I've got the answer. And omega is 2 pi, 2 pi over which is 1 point. Okay, what did you get? Very good. 0.4186 I got, but I'm not maybe not being accurate. I'm going to go with 419. Okay. And Tanish, I'll pick on you again. When will this maximum acceleration happen?
Highest point.
Very good. Okay. Next we have to do the graph for the energy. So here is energy. What's the unit for energy? Joules. And then here is displacement, x. What's the unit for displacement? Meters. Okay. In red will be kinetic energy. At the beginning, when there's no displacement, for example, kinetic energy is high or low? No, high. Because when it's at the lowest point, that's what I meant, sorry. Alright, now let's do it the other way. Let's say we pull it back. Now it's at its highest point. Kinetic energy is 0. And then we let go and it increases. So here it's at the A. It's no kinetic energy. And then it increases steadily and then decreases, and then here is minus A, and this is kinetic energy. Now, in blue, potential energy. There's maximum at the start, and then, yeah. That's potential energy. And by the way, total energy is what? Potential energy plus kinetic energy, which...
287 degrees.
Yeah, sorry, that's not...
Sorry.
I should have these really at the same heights. That is total energy. Full marks, 3 marks. Okay. You got that part? Yeah. Okay, so next part, have a look at that. Determine the total energy of the bob if its mass is that. Okay. There is a formula here. You think you can remember?
Half Ka squared.
Yes. Although the problem is you don't know the K, do you?
Yeah, so we can change the K into.
Yeah.
Half
What's that? Yeah, I think also we also can use kinetic and potential.
half
Yeah.
half
Yeah, we're all getting to the right idea. I think that formula for the K, for simple harmonic motion, works well when we're dealing with springs, because we usually are given the K, or we're asked to find the K. Did they ever ask me to find the K here? No. So I feel like this maybe, although it would work, is not the best way to do it. We should look at potential and kinetic energy. Now, total energy. You could say the total energy is the same as the potential energy at the start, because at the beginning, the only form of energy it has is what? Potential. Now, when it's down here, the only form of energy it has is kinetic. So we could say total energy is the potential at the start or the kinetic at the bottom. Which do we choose?
Kinetic.
Kinetic at the bottom because? Exactly, we have the V at the bottom. So in fact, this is just a kinetic energy calculation. Total energy is kinetic energy at the bottom. So that is a half Well, what was my V, by the way?
0.121.
Thank you. Squared. All right. I got really small number. Yeah? Oh, because the mass is so small. I got really, really, really small. Yeah, I got like 0.329 millijoules. Or if you don't want to write it like that, if you want, you can just write it as 3.29 times 10 to the minus 4 joules. It's tiny. Okay, last part. If the length is changed, or what is the length if the frequency is 0.75 hertz? So what is the length? Yeah, well, no, yes, you're right. No problem here, because frequency is 1 over time equals 0.75. So that means time is 1.33, huh? Let's double check that. Okay, I'll believe you so. 1.33 seconds, thank you. Now, time is 2 pi root L over G. So we just want the L here. So we can say L equals 1.33 divided by 2 pi squared times G. If I do some rearranging there. Zero point four 0.44 about, isn't it? Yeah. What is it?
0.443.
Thank you. Meters. Yeah. In other words, roughly 44 centimeters. Roughly. Okay.